Hello everybody, it's Tim from Tech with Tim, and in this video, I've teamed up with Linode to show you how to build a simple Python chat application. Now, what we're going to be doing in this video is building out a client and a server, and the purpose of this client and this server is going to be to communicate with each other in the form of messages. So we're going to try to build kind of a online messaging room or chat room, whatever you'd like to call it, and the idea is we'll have one centralized server. We'll have multiple different clients. Those clients can all connect to the server, and then those clients can send messages to the server. And when a message is sent to the server, it will be transmitted out to all of the other clients. So I'm not only going to be showing you how to build this out, I will also be showing you how to deploy this to a Linux virtual private server using Linode. So with that said, let's dive in. So I'm here in Visual Studio Code, and we are now ready to start programming out this project. Now I will give you a little bit of a warning. Based on the way that we're going to be implementing this and just this type of application in general, it's very difficult to test this app until a majority of the code is written. So there will be probably about 20 or 30 minutes of just sheer writing code before we can actually test anything. With that said, it's very common that you're going to run into bugs or mistype something. So if you're having any issues and you can't figure it out by watching the video, I will have all of the code that I've written in this video linked in the description. It will be a GitHub repository, so feel free to reference that throughout the video if you're getting lost or if some of your code just isn't functioning. With that said, I'm in Visual Studio Code. Open up any text editor. You can use whatever you'd like. I just prefer VS Code. And inside of here, I'm going to start by creating 3 files that we'll need for this project. Now, of course, you're going to need Python installed. Once you've got Python installed, that's really the only dependency. So the first thing that I'm going to do here is create a file called server.py. I am then going to create another file called client.py. And then I'm going to create one called list_messages.py. Now, again, the idea here is we'll have one server. This server will handle all of the connections from the different clients. And then every single time a client sends a message, and that's all this client file will do, it will just send a message to the server. That message will get collected and then sent to all of the other clients. Now, this list messages file, what this will do is actually show us all of the messages that are appearing on the server. So since our client is going to be sending messages, we're not actually going to be able to view all of the messages from this script. We'll kind of need a separate script that will be running to show us all of the active messages and all of this stuff appearing. Now, what we're going to do is run this localhost. So we'll kind of do all of the dev work and debugging here. And then once this server is finished, we will deploy this to Linode. Now, just a quick reminder here, if you do not already have a Linode account, you can claim $100 in free credit towards a new Linode account by signing up at the link in the description. And I'll mention that again once we actually get into deploying that. So now that we have our server and our client and our list messages, the first file that we're going to be working in is our server file. And we're going to get started by importing a few things. The first thing we're going to import is threading. Not Django. I don't know why it gave me Django. I'm going to import threading, and we are going to import socket. So both of these modules are built into Python, so you shouldn't need to install them. And now that we've got socket installed, the first thing that we're going to do is build a socket. Now, a socket is kind of just a way for 2 devices to communicate with each other. So there's some information about the socket that we need to define, like the socket type, the different addresses this socket is going to accept, the IP address or the host of this socket, and all of those other kind of things. So that's what we're going to do right now. We're going to start by defining our port, which is going to be equal to 5050. Feel free to use any port number that you like that is available on your machine, but 5050 is usually a good go-to. We are then going to define our server. Now, our server is going to be the IP address of the machine that's running our socket. Now, when we want to just run this locally, what we're going to do is just insert localhost here. But if you were going to run this on a virtual private server, or you wanted to run this on like your local area network, then you would put the IP address of your machine, of the machine that's running this on it. And I will actually show you, I'll just copy and paste this line in here. This line will give you the IP address of this machine, and I believe this will give you the local IP address of the machine. So if you use this line here instead of localhost, it will give you the IP address of this machine, so you don't have to manually go and find it. Anyways, we'll deal with that later when we actually host this. For now, we're going to leave this at localhost. Next, what we're going to do is create an address. So ADDR, standing for address, is going to be equal to, and then our server and our port. Now, the reason we need this is when we bind this address to our socket or kind of tell our socket to use this address, it needs to be in the form of a tuple or a tuple, whatever you call it. So server and port. Next, we're going to define the format of our messages. So we're going to say format is equal to and then UTF-8. There's other formats that you can use, but this is the most standard. And then lastly, we're going to create another variable that we'll use later on called disconnect message. This is the message that's going to be sent to the server when a client disconnects. Now, in this case, the message we'll use is exclamation point and then disconnect. Feel free to make this whatever you like, but try to make it something relatively unique so that someone's not going to send it as a regular message and then accidentally be disconnected from the server. And again, you'll see why we need this in a minute. So now that we have the address and we have the port, what we're going to do is actually create our socket. So we're going to say server is equal to and then socket.socket. And inside of here, we need to define two things. We need to define the address family and we need to define the type for this socket. Now, I'm not a networking expert, so I'm not going to explain why we are picking these types. This is just the standard types that you're using when you're using sockets and kind of the most common. So what we're going to do is say socket.afinet. Now, what this actually stands for is IPv4 addresses. So we're saying the family of addresses that are going to be accepted by this socket is IPv4. And then the type of this socket is going to be sock stream, which stands for TCP. So that's the method. So we're going to say socket.sock_stream. Keep in mind, there's other methods you could use here like UDP. And if you don't know about those different methods, don't worry about them. It's just the different protocols for transferring information over the internet. So anyways, we are using IPv4 addresses with a TCP socket. That is what we've defined here. Now that we've created this socket, what we need to do is bind this socket to an address. So we're going to say server.bind, and we're going to bind it to ADDR, which is the address, should just be ADDR that we defined above. Now that we've done that, we need to actually start the socket and start listening for connections. So what we're going to do is define a function here. We're going to call this start. And what this start function will do is handle all of the operations relating to starting our socket and listening and handling different clients that are connecting. So we are going to start by saying define start. We're going to say server.listen. And what this means is start the socket, start listening on this address and this port that we've binded the socket to. And now what we're going to do is listen for connection. So we're going to have a while loop here. We're going to say a while true. And what we're going to do is say comma ADDR equals and then server.accept. Now, what this will do is infinitely wait and try to accept incoming connections from clients. So every single time we get a connection, what we will have is the connection and the address of the thing that was connected to the server, so the address of the client. And then what we'll need to do is start some type of thread or start something that can actually listen for all of the messages being sent by this client. So what we're going to do after this is we are going to say thread is equal to, and then this is going to be threading.thread. And inside of here, we're going to say target equals, and then we're going to say args equals, and we're going to pass con and ADDR, and we're going to set this target in 1 second. Now notice we imported the threading module here. Just to briefly explain what's going on, every single time we get a connection, and sorry, this should be indented, we're going to create a new thread. Now, what a thread is going to allow us to do is make it so that we are not blocking other clients from sending messages or blocking our server in particular from receiving messages from other clients when some client is kind of idly not doing anything. Now, I understand that's probably a poor explanation, especially if you're not familiar with what a thread is, but the reason we need a thread is because every single time we receive a connection from a client, we kind of need a separate function, let's put it this way simply, to handle all of the stuff and all of the communication with that client. So we need one function that's going to kind of sit there and just wait for this specific client. And keep in mind, we're going to have multiple clients to send us a message. So while we are waiting for a message to be sent to us from a client, we want to ensure that other clients are also able to send us messages. If you do not create a thread, what's going to happen is that while we wait for a message from one client, other clients will not be able to send us a message, because this waiting operation is what we call a blocking operation. And that means that it must finish, that line must, occur, like something must be sent to the server before we can move further in the program. So what this thread allows us to do is kind of pause the execution of one of the threads while another one is running. So if we have a thread that is like waiting for the client to do something, then other threads are allowed to be running in the background so we can accept messages from other clients. And then as soon as we accept a message from another client, that thread will kind of be released, and we will then go into another thread, which will allow us to receive a message from another client. And this is a very high level and not super accurate explanation of threads. I just am trying to give you an idea of why we need a thread. So if you're unfamiliar with threads, I recommend you look up threading and do a little bit of reading about threads versus processes. But the idea is that we want to make sure that one of our clients is not blocking other clients from sending information, and hence we need a thread. This is a very common practice in networking operations. You have multiple threads because there's going to be a lot of times where you are just waiting for something to happen. And in the time while you're waiting for something to happen, you want other operations to be able to take place, like accepting a new client, right? If we didn't put this in a thread, then we would not be able to accept a new client. We wouldn't be able to have a message sent from them or even allow them to connect to the server while we were waiting for one of the existing clients to say, send us a message. So that's the idea here, but the target needs to be equal to a function. And what this is going to do is create a new thread that runs a function. So the function that we're going to define here is handle client. And inside of here, we are going to take a connection object and an address of that connection. And then we'll just say pass for now, but our target will be handle client. So the idea here is we will run this function with these arguments, connection and address, every single time a new client is accepted. So now that we've created the thread, we must start the thread. So we'll just say thread.start, and that's pretty much all we need for inside of here. So now we are able to actually listen for connections. What I'm going to do is call this start function, and now we need to code out the handle client function. And before I do this, actually, I'm going to define something called a lock, which we need to use when we're modifying the same data structure from different threads. So what I'm going to do is create a set. I'm going to say client is equal to a set, and I'm going to say that my client underscore lock is equal to, and then threading.lock. So I will explain what a lock is as we start using it here, but since we want to send the same message that we receive to every single client that is connected to the server, we need to keep track of all of the clients that are connected so that we can, well, send the message to all of them. So to do that, every single time a connection is accepted, we are going to add the client to this client set. So we are going to say with, and then client underscore lock, and we're going to say client dot add. I think that's correct. Let me just look at my notes here. Yes, that looks correct. And we'll add the connection object. Now, just as a refresher here, this connection here, con, is a connection object, which is really a socket. It allows us to send messages and receive messages from a specific client. And then this address is just a string that represents the IP address and port that this client accepted from, or joined the server from, sorry. So the reason we need this lock is because we have this data structure, and this data structure could potentially be modified by multiple objects or multiple threads, sorry, at the same time, because we're going to have multiple threads running. So we want to make sure that every single time we access this data structure, there's only one thread modifying it at the same time. So this is very common in, say, databases, for example. You want to make sure that your data is persistent and stays the same across all threads. If you have threads modifying objects without locking it before you modify them, what that means is that two threads could theoretically modify the same object at the same time, which would mean each thread would have a different copy or different idea of what that object looks like. So all this lock does is make sure that we are not able to start modifying this data structure or anything really, while another thread is in the lock. So when I say with clients underscore lock, what this does is lock all of the other threads from modifying anything to do with this client's data structure, essentially. We will then modify the client's data structure, and then we will release the lock after we get out of this with statement. So anything that you would only want to happen once per thread, or you don't want to happen at the same time between multiple threads, you would put inside of this with statement. So hopefully that's clear, but that is the idea behind this lock, and it's very important that we use them for the different operations we're doing here with multiple clients. So now that we have that, we're going to code out handle client. Inside of handle client, the first thing I'm going to print here is just that a new connection was accepted, just so we have some nice output from our server. So I'm going to use an F string, only available in Python 3.6 and above. And I'm going to say new connection like that. I'm going to say ADDR and then connected. Now, the idea here is we're going to be given the IP address of the connection. So we will print out new connection and then whatever the IP address is, and then connected at the beginning of this function. And in fact, at the beginning of our server here, let's just print something out and just said server, oops, what the heck? What's going on here? I wanted to say server in all capitals, server started, just so we have some output to say, the server did indeed start. And we need a lowercase I here. Still don't know how I managed to mess that up. Okay. Anyway, so there we go. We have a new connection. Now inside of here, what we're going to do is define a try statement and a finally statement. Now, whenever you're using like sockets and just networking operations in general like this, it's usually a good idea to throw the stuff you're doing inside of a try statement, because there's a lot of errors that could occur. For example, if the client is connected and all of a sudden their power goes out and their computer turns off, well, that's just not going to be handled very well from our server. There's going to be an exception that's thrown, and we would like to catch that and cleanly exit with the try and finally statement. So inside of try, what we're going to say is while true. And what this while statement will do is run infinitely while our connection is connected to the server. So hopefully you get the idea here, but this will be run in a new thread for every single client. So we will be able to handle all of the messages from all of the clients. So inside of here, actually, instead of saying while true, I'm going to say while connected. And above here, I'm going to say connected equals true. And then what I'm going to do is I'm going to wait for a message to be sent to us. So I'm going to say message equals, and then this is going to be con.recv. And then inside of here, we have to put the length of the message that we're looking to accept. So every single time a message is sent through a socket, it has a certain size. Now we need to kind of pick what the maximum size of our message should be, and we'll put that in here. Now there's other ways to make it so we can have dynamically sized messages, but for our situation, we're not going to be sending anything super large. So we'll just put 1024, which stands for 1024 bits, or sorry, I'm pretty sure that's bytes actually, 1024 bytes, which is the length of the message that we're looking to accept. Now, just keep in mind here, if you do send a message that is larger than this, then you're only going to get the first 1024 bytes, and you'll get an error that says that this message was truncated because you could not accept the entire message because you were only looking to receive this many bytes at a time. So you can mess around with this value and see what works for you, but 1024 should be perfectly fine, at least for our purposes. Anyways, so now that we have the message received, what we need to do is decode the message, and we'll decode it using the format that we defined above. So in sockets in Python version 3.6 and above, I'm pretty certain that you need to encode all of your messages. What encoding will do is just take it and translate it into a binary form, and then you need to decode that message so that you can actually get the string representation of it. Because if you just print the message when it's not decoded, it's going to look like a bunch of gibberish because it would have been encoded when it was sent to the server. It's just kind of a requirement from Python that you now must encode and decode messages using the format that you define, which in this case is UTF-8. So now we have a decoded message. The first thing we're going to check is to make sure we actually did get some content in this message. So we'll say if not message break, the idea being if we did not receive any content in this message and it was completely empty, something went wrong, we need to stop and we will disconnect this client from the server because again, something went wrong. Now, the next thing we're going to check is if the client sent the disconnect message. So we're going to say if message is equal to disconnect message. Disconnect message we defined up here, the idea being that whenever the client wants to disconnect from the server so that we can handle it cleanly, they will send this message. So when they send this message, the server will realize that it's being sent this, and then we will cleanly disconnect this client from the server. So we're going to say connected equals false. And now that connected is equal false, that means we'll exit out of this while loop and then we can disconnect the client from the server. But before we do that, we want to print out the message that was sent from this client, and then we want to send that message to all of the other clients. So we're going to say print, we're going to use an F string. We're just going to say, I don't know, inside of here we'd say ADDR, And then here we'll say message. The idea being that inside of square brackets will be kind of like the name of the sender, and then this will be the message. We're just printing this out on the server so that we can see what was sent. Then what we're going to do is look through all of the clients here that we're storing and send this message to all of them. So now under here, we're going to say with clients lock. And again, the reason we need the clients lock is because we're going to be using this data structure. We want to make sure it's not modified while we're using it. Otherwise, we'll result in some errors here. So we're locking the fact that we are now currently using this data structure so no one else can touch it, no other threads. And now what we're going to do is say for C in clients. And we're going to say, oops, don't even know how I managed to run the Python console there. Let's close this. So for C in clients, we're going to say c.sendAll. And what we're going to send is the following. Actually, this message right here with the F string. And then this is going to be dot encode, or sorry, inside of here, dot encode, and we're going to encode it with the format. So we're going to take this string, and the way the F string works, if I haven't explained it, is when you have these little curly brackets in here, it will take whatever expression, which is just Python code, that is written in this, and it will evaluate it as a string. That is if you put an F before the string, either a lowercase or uppercase F. Notice that when I remove that F, the syntax highlighting is different because it doesn't understand that this is actually a Python variable. But when I add the F, it knows it is. And then I'm going to take this string and I'm going to encode it using the UTF-8 format and then send it to my client. Then that's actually all we need for the while loop. So what this will do is just handle all of the messages. Every time we get a message, we'll check if it's disconnect message. If it's disconnect message, we will disconnect. If it is not a disconnect message, then what we will do is we will print out this message, then we will send it to all of the other clients. Now notice we technically will send the disconnect message to all of the other clients. That's fine. You can choose whether you want to do that or not. If you don't want to do that, you just put a break here and it won't send that message. All right. So now that we've done that, we're going to implement the finally. So this finally is like when we are done this while loop, or we exit out of this try with or without an exception, we want to run this. What this is going to do is remove this client from the client's data structure here, which is a set, and it is going to close the connection. So we are going to say with clients lock, we're going to say clients.remove, and we're going to remove the connection object. And then we will say con.close, and this will cleanly close the connection. So that should be all good for our handle client function. I'll zoom out so you guys can read it a little bit better. And that's what we have right now. So I'm just looking at my notes here to make sure I haven't missed anything. I think that's actually all we need for this server. Again, let me do one quick check here. Yeah, it looks to be all good. So let's save this. And now let's move over to the client. So actually, before I go to the client, I'm just going to copy the first, let's say 11 lines of this code, because we're going to use pretty much the exact same starting lines here inside of our client file. So I'm going to copy all of that, paste that here. I'm going to remove the threading import because we don't need that. And then when we actually create this socket, instead of saying bind, I'm going to say connect. The idea being that we are connecting to an already existing socket. We're not binding or creating a new socket that is like listening for connections. So what I'm going to do is I'm going to now code out the client. And what the client is going to do is just connect to this socket, to this server, and it's going to send messages to the server. That's all the client's going to do. Then this list messages file, what this will do is actually receive all of the messages from the server. Now, it's worth noting that typically when you create a client, you can actually send and receive messages from it. Just based on the way that we're going to implement this, it's a lot easier to separate out into two files. So I'm going to create a function here, and I'm going to say define, actually, we'll say define connect like that. And what this is going to do is say, instead of server, it's going to say client. So let's say client equals socket.socket, and then not s client, but client equals, or client.connect ADR, and then return client. So what this will do is kind of create the connection object to the server. So we will set up the socket. Again, we need to define what type it is, the address family, and all of that. We then connect the client and we return it. So now that we have that, I'm going to show you how we can send a message. So I'm going to create a function here and call this send. This is going to take in the client and is going to take in the message. And all this will do is just send the message to the client. Really straightforward. Or sorry, send the message to the server, not the client. This is the client, but it's easy to do this. So to do this, we're going to say the message is equal to msg dot encode, and we're going to encode this with the format of UTF-8. Then all we're going to do is say client.send, and we're going to send the message. So what this will do is just take the message, send it over to the server, and we'll be all good. So if we go over to the server here, what's going to happen is when we connect to the server, we're going to create a new thread. So we're going to run this function with this connection object. And then what's going to happen is we're going to come in here. We're going to print out new connection. We're going to run this while loop, and we're going to wait for messages to be sent to us because we're waiting to receive messages. As soon as we receive a message, what we're going to do is do all these checks, print it out, send it to all of the other clients, and we'll be good to go. So we're going to run this server now, and then I'm going to run this client in a second. In fact, to run this client, what we need to do is say client equals connect, and then we need to say send. We need to pass the client and the message, which we will say is testing. So now that we have this, we can run the server. So to run the server, I'll do this, just do this in VS Code. I'll press run. Notice it says server started. I'll now create another terminal window. I think I can split this over. Actually, is there a way that I can split? Yeah, let's split this terminal and then I can run it in here. So now I'm going to say Python client.py. And when I do this, notice it said connected, and then we got an error. It says a bytes-like object is required, not string. When I sent this message, oh, that's interesting. The reason we got this error here is because if I go to client, it's telling me that here I need to send a bytes-like object, not a string. I accidentally sent MSG, not message. So this is what I was talking about with encoding. We need to encode the string as bytes. So we just need to send the message instead of MSG because MSG is not encoded, but message is encoded. So now if I change this and I go back here and I run this, I'm going to have to run it one more time, but you did see that the testing message did actually appear. But notice that what happened was that we connected again, then the testing message appeared, and then we got this error. It said an existing connection was forcibly closed by the remote host. What that means is that we didn't disconnect cleanly. Our script just stopped running, and we didn't disconnect from the socket before the script stopped running. So what that means is that we need to tell the client that we are disconnecting before we actually exit our code or stop running our code. So we're going to send client the disconnect message after we're done sending the testing message. And now you'll see that we won't get this error when I run the client. So now that I run the client, we still got the message. I guess, we got testing, and then I got exclamation point disconnect. I'm just going to stop the, server and rerun it because I think we just had an issue because we had messed up the first time. Anyways, let's try this. So I'm going to stop all of this. We're going to run the server again. This is debugging for you. We're now going to split this. We're going to say Python client.py, and we still get an error. Okay, so I'm going to have a look at this quickly, and then I will be right back. All right, so I've just reran the server here, and I've found the error. This was a really silly error, but the idea was that when we were sending these two messages, they were sending so quickly that our server was accepting them as one single message. So we were getting a kind of a smushed message that said testing and then disconnect message afterwards. So it wasn't cleanly disconnecting us because it wasn't just seeing this message as its own message. So what we need to do now is we need to add this input here, which is what I've done. And what this will allow us to do is kind of wait a second before we send this disconnect message so that the messages aren't coming in too fast. So we will send testing, and then we have to press enter on our keyboard. And then as soon as we press enter on our keyboard, it will send the disconnect message. So again, the server is rerunning. I'm just going to run the client over here. So let's go Python client.py. And then notice it says testing. Now, if I hit enter, it says disconnect. My client script's now done. And notice we didn't get any errors, on the server side. So I think that is all good. Let me run Python client.py one more time. Notice it says new connection. We connected, it says testing. Then I press enter, it disconnects us. Everything's working. We're not seeing any error messages popping up, and we are all good. So with that said, that is going to conclude part 1 of this tutorial series. In the next part, what we will do is deploy this to Linode. We will also work more on this client and list messages script. And yeah, that's all for part 1. So I hope you found this useful, and I look forward to seeing you in part 2.